Hey guys, the question would like to know which of the following could act as an appropriate starting material for the reaction shown. Now if you look at our answer choices here closely, just sort of roughly looking at it, you see it's all alkenes, and you see we added Br2, the bromine, and then added to the alkene, and so it's basically just an alkene addition reaction. And remember, I always say this, with your alkene addition reactions, for every single one of them, you have to be able to answer two questions. One, what is the regiochemistry? In other words, is it Markovnikov or anti-Markovnikov? And two, you should be able to answer what is the stereochemistry? Is it syn addition or an anti-addition? Okay. So if you know that for every single alkene addition reaction, you really should be fine. Okay. In the case of Br2, it's tempting to say that there is no stereochemistry with the Br2. There's going to be no regiochemistry. Sorry, not stereochemistry, regiochemistry, because you're adding two bromines, right? So what does it matter which bromine adds to the most substituted side and which one adds to the least? Well, actually, there are some compounds, especially think bridgehead compounds where one side is kind of blocked, where that actually will matter. And Br2 for the regiochemistry is said to be Markovnikov-like. In other words, the second bromine that adds will add to the most substituted side of the carbon of the alkene. I won't do it in this video, but if you really want to see how that happens, ask yourself what would be the final product of adding Br2 to this alkene. And you'll see it actually matters which alkene adds first and which one is second, and how it happens. So ask yourself, what's the product of adding Br2 to this? And you'll see exactly what I mean by that. Okay, so this reaction is Markovnikov-like. Okay, and then for the stereochemistry, it is an anti-addition, right? And that's very simple. Remember, if you have the alkene, what's first going to happen is, if you look at the mechanism, the first thing that happens is the alkene attacks the bromine, and the bromine attacks it right back while kicking off that second bromine, and you get what is known as the bromonium ion, like that, okay? And then this bromine that got kicked off, the second one, comes around and does a bit of a backside attack, basically on that ring, from the opposite side, which is why they will add anti to one another, okay? So in other words, if you started with, let's say, a ring like this, and you say Br2, you get the two Brs anti to one another. They'll be trans. It'll be a trans dibromination, like so. Okay, so it's an anti-addition. Markovnikov-like and anti. So you see, for your alkene reactions, you always have to be able to do it this way. You have to say, what is the regiochemistry and what is the stereochemistry? Okay, now that we know that these two bromines added bromine, I want to kind of backtrack my steps. I want to kind of work, sort of go back into the past and see where did this compound exactly come from. So to do that, first thing I need to do is I say to myself, okay, what did this, if I were to be able to sort of play this reaction back in slow motion. So let's say I just look at this one type of reaction and I can shrink myself down, and I'm standing next to this molecule and I'm pressing sort of a rewind button, and I'm rewinding it in slow motion. And I get to the point, sort of, let's say I get to the very first frame right after the two bromines added. So like the very moment that the bromine attacked the bromonium ion, right? What did that compound look like? Well, it was an anti-addition, which means that at that very moment, the two bromines had to have been anti to one another, okay? They had to be pointing away from each other. And then, of course, once they're added, it's a single bond in between these two carbons, and then they start to rotate, which is why we can draw the molecule as a Newman projection like this, with the two bromines not anti to one another. But the very moment that it was formed as an anti-addition before the compound started rotating. Okay, so clearly I didn't move the back bromine, so the phenyl here stays where it was, and so goes the ethyl, goes down here. But I moved this bromine over there, so this hydrogen goes here, and this ethyl goes up there, so CH2, CH3, like that. Okay. So that's my compound, what it looked like right after the addition of the bromines. And so now I backtrack even further. So if I took these two bromines away, I'll get an alkene that will have the phenyl and the ethyl next to each other, okay, but on different carbons. That's very important. Don't draw the phenyl and the ethyl coming off the same carbon. You can clearly see they're not bonded to the same carbon. So there's the CH2, CH3. And then you have, so there's the phenyl, and then you have the ethyl and the hydrogen on the same side. So here's CH2, CH3, and hydrogen over there. Now let's just look at our compounds and see which one that is. Oh, and lucky for us, compound A is already the correct compound. All the other 4 choices we can clearly see are not correct. So the correct answer here is definitely going to be A. This is a great question, guys. Make sure you understand exactly how to do this. And you know, even if you've seen the answer, go back and redo the question. Do it for yourself. See if you can figure it out this way. See if you can do this working backwards method of figuring out the addition, because it's a fantastic way of really seeing, do you understand how these alkene addition reactions work. All right, so this is a tricky one. If you have questions, email me and I'll be happy to explain it in more detail. Have a nice day.